Alaikum wa rahmatullahi wa barakatuh. According to the emails I received from some of you, I will do the muscular system 2 also for you, and it will be available from today. Okay. What are the expected learning outcomes? We need to explain the bone and muscle relationship based on the general principles of the liver system. Describe the arrangement of the muscle fibers of the body and related to their function with giving example. List some criteria used in naming muscles and give examples. Demonstrate or identify the different types of body movement. Name and locate the major muscles of the human body on a torso model muscle chart or a diagram, and state action of each. Let us start. What is the microscopic and functional anatomy of the skeletal muscle tissue? Okay, the skeletal muscle fibers, the fibers are long and cylindrical. They are huge cells. Diameters are 10 to 100 micrometer. The length several to dozens of centimeters. Each cell is formed by fusion of embryonic cells. Cells are multinucleated. Cells are multinucleated. Cells are multinucleated. Okay. Nuclei are preferably located beneath the plasma membrane, which is called sarcolemma. Okay, I want you to review the histology of the skeletal muscles. Let us make a summary for the histology of the skeletal muscle. As you know, the skeletal muscles are striated muscle, multinucleated, under voluntary control. You remember that, and you remember the comparison between the skeletal muscle and the cardiac muscle and the smooth muscle. Let us see the picture of the structure of the muscle fibers. Here is the sarcolemma. The sarcolemma is the outer fibrous sheet which surrounds the groove of the muscle fiber, right? And this striation will appear in the form of dark A band and light A band, right? Each muscle is formed of multiple of myofibril. This one is the myofibril. Surrounding the myofibril is the mitochondria. When you remember the structure of the cell, is that organ which is responsible for the production of energy. Let us revise this definition. Striation results from internal structures of the myofibril, results from the alternation between the A and M, the dark and light bands. What is the myofibril? I received an email from one of you asking me about the difference between the myofibril and sarcomere. We will explain it now. Myofibril are long rods that appear striated due to alternated band of actin and myosin proteins. The actin and the myosin proteins these are the two types of proteins which share in the formation of the muscle fiber. The myofibrils are separated by regions or sarcoplast which contain a lot of mitochondria. As we agreed, it is the organelle responsible for the production of energy, and the glycosomes for energy. Several myofibrils together make up a sarcomere. The sarcomere is the basic unit of contraction of the skeletal muscle. Pounds of boundaries of the sarcomere are called Z-disc. Z-disc have many thin filaments of actin connected to each end, which overlap the thick myosin filament which occur in the center of each sarcomere. Okay, so the striation results from what? From the internal structure of the muscle fiber. What is the myofibril? The myofibril are the long rods which appear in striation due to alternation between the arrangement of the two proteins which form the muscle fibers, which are the actin and the myosin. What is a sarcomere? Is the basic unit of contraction of the skeletal muscle. These three definitions are very important to know, right? Let us discuss the sarcomere structure. Dark bands of the sarcomeres are the A bands, which correspond to the full length of the thick filaments, which overlap the thin filament. The thin central part of the thick filaments with no overlap is the H zone with an M line down the middle. The site of the only thin filament is the I band. Myosin filament contain small globular heads which interact with the same filament as a cross bridges. The picture can define the picture. From the picture we can understand more the structure of the sarcomere. The sarcomere extends from one I band to the second I band, right? Under electron microscope, you can see the thin actin myofilament and the thick myosin myofilaments. Thin actin myofilament and the thick myosin myofilaments. This is the structure of the sarcomere under the microscope. What are the different types of the skeletal muscle fibers? We define the we differentiate the muscle fibers into three types: red slow twitch, white slow twitch, and intermediate slow twitch. This division, okay, notice that we divide the muscles according to their three main classes based on their strength, speed, and endurance. This is how first classification of the skeletal muscles. Depend on the first classification of the muscle fiber depend on their strength, their speed, their endurance of contraction. Most muscle contain all three types: red slow twitch, white slow twitch, and intermediate fast twitch. Let us have an example of the red slow twitch. The red slow twitch are red colored due to abundance of myoglobin. We agree that the myoglobin is a protein of the muscle. Contain large number of mitochondria, means it needs a lot of energy. Richly supplies with capillaries to supply it with the required oxygen for its action. Okay, contract slowly and resistant to fatigue to deliver prolonged contraction. The example is the extensor muscle of the back, slow but steady. Here, as we mentioned, the latissimus dorsi or the swimmer muscle. We will learn it in the next lecture, that the latissimus dorsi or swimmer muscle. You imagine the action of swimming. We need the muscle to contract. We need the muscle to be resistant to fatigue. We need the muscle to maintain its prolonged action. And all of these, we can apply to the swimmer muscles of the latissimus dorsi, right? So, to do this action, the muscle should have a good energy through the large number of mitochondria, should have a rich blood supply through the blood capillaries to give it the required oxygen, to release the required energy, to make the prolonged action and prevent the fatigue. Second type is the white fast twitch fibers. These white fast twitch fibers contain little myoglobin and few mitochondria. They generate much more power, contract rapidly, and fatigue quickly, and are used for a brief period. The best example for this are the muscles of the arm. You imagine that you want to look laterally or upward or downwards. This movement just takes a second, right? So the amount of the myoglobin in the eye muscle will be few. Also, it needs a few mitochondria, because it needs a few energy, right? But it contract rapidly and fatigue quickly. You cannot maintain your eyes looking laterally or looking anteriorly or posterior and so on. Then the intermediate fast twitch fibers. They contract quickly, have high myoglobin content, somewhat fatigue resistant, more powerful than red slow twitch, abundant in muscles of the lower limbs. Right? Like the most common example are the calf muscle and hamstring muscle. In the football player, you know that they make excessive exercise over the hamstring muscle to work properly, over the calf muscle to work properly, to allow them to do its function. So they are fatigue resistant. They are more powerful than red slow twitch fibers. Okay, so this is the first classification of the muscle. Depend on its amount of the myoglobin, its endurance for fatigue, its reach, its blood supply of the capillaries, and amount of the mitochondria. Right? The muscle of the body, we agreed that movement of the muscle, contraction of the muscle, lead to movement of the joints. I'm right? The different muscles of the body produce different movement, as blinking of the eye, standing on tiptoe, swallowing the food, everything, every movement we are doing are result from contraction of the muscle. The bone and the muscle relationship is based on the general principle of leverage. You remember the leverage which we learned in the secondary school. Muscle act with or against each other. The movement of the skeletal muscles involve leverage. Always the skeletal muscle and the bone relationship belonging to the leverage system number 3. Okay, the lever is a rigid bar that moves. The auriculum is the fixed point. The effort, which applied force. Load means resistance. Bones act as a lever. Huh. We apply the lever system here to our bone and the joints and the muscle. Notice, bone act as a lever, joint as a auriculum. Muscle contraction provide effort, applies forces where muscle attaches to bone. Then the load, the overlying tissue, and anything you left. Okay, so the bone resemble what? Resemble the lever, the joint, the folliculum. The muscle contraction provides the effort. The load comes from anything you lift. This slide just to remind you about the lever system which we studied in the secondary school. The most common, the most important for us is the third class. Effort applied between the load and the curriculum. Example, tweezer. This applies to most of the muscle of the body. Underline this. Most of the muscle of the body are belonging to the third class of levers. Okay, understand? Type. The bone present the lever. The joint present the folliculum. The effort done by contraction of the muscle. The load is something you have, the something you carry. The load is the something you carry. The load is the something you carry. Anything you lift. Let us apply this on, for example, upper limb. The flexors of the upper limb. In the next lecture, you will learn that the anterior compartment of the upper limb are flexors. Okay, type. This means that I wanted to carry my book, right? So the lever here will be the humerus bone, right? The auriculum will be the elbow joint. The effort is the contraction of the flexors group, which are three muscles: brachialis, brachioradialis, and biceps brachialis. They will contract, and the load is the heaviness of the book that I will carry. This is how we apply it. How we apply the third class of levers over the muscle system, the muscular system. Okay. Second classification of the muscle. We did a classification of the muscle according to the abundance of the myoglobin, the endurance, the amount of the mitochondria. This is the first classification. Second classification according to the arrangement of the fascicles in the muscle. Skeletal muscles consist of fascicles. Fascicles arranged in different patterns. Fascicle arrangement and the shape tell us the action of the muscle. How the muscle fibers are arranged, this will tell us the action of the muscle. What types of the fascicles? First example, parallel. This means that the fascicles run parallel to the long axis of the muscle. Strap-like sartorius. Strap-like, they are parallel to each other like sartorius. Fusiform. They are narrow at the start, narrow at the end, and half circle in the middle, like the biceps brachii. Or convergent. Origin of the muscle is broad, like the pectoralis, and their insertion is very narrow. This is convergent arrangement, like the pectoralis major muscle. Wide origin and narrow insertion. This is the pectoralis major muscle. Pinnate. Pinnate. We have unipinnate fascicles insert into one side of the tendon, the example extensor digitorum longus. Bipinnate as the rectus femoris. The fibers are parallel to each other with a central tendon in between. Multipinnate, the fascicles insert into one large tendon, example the deltoid. Then circular, the fascicles are arranged in a circular pattern, like the orbicularis oris. We learn it in the next lecture. Orbicularis oculi, around the rounded muscle or the circular muscle around the eye, and orbicularis oris, the circular muscle around the mouth. Also, the sphincter, it is a general name for a circular muscle. These are the different shapes of the muscle, right? Circular, like the orbicularis oculi and the orbicularis oris. Convergent, like the pectoralis major. Fusiform, like the biceps brachii. Parallel, like the sartorius. Multipinnate, like the deltoid muscle. Unipinnate as the extensor digitorum longus. Then bipinnate as the rectus femoris. This is the second classification of the muscle according to the arrangement of the muscle fascicles. First classification, red, white, and intermediate slow to each muscle according to the abundance of the myoglobin or mitochondria. Okay. Then, according to the arrangement of the fascicles or the muscle shapes, right? Muscle work together to bring about a desired movement, right? Muscle cannot, these rules, right? These rules. Muscle work together to bring about a desired movement, right or wrong? Muscle cannot reverse the movement it produces, right or wrong? We have a flexor and extensor. Another muscle must undo the action. This is a rule. The extensors group undo the action of the flexors group. Muscle with opposite action lies on opposite side of a joint. I will learn you next time, or you can write this rule from now. Anterior compartment of the upper limb are flexors, while the posterior compartment of the upper limb are extensors. In the lower limb, the anterior compartment are extensors, while the posterior compartment are flexors. Clear? These four rules are very important. So, to do a desired action, a group of muscles should work. Right. We will have an example of that. Flexion of the elbow. The group of muscle which form a flexion of the elbow, we called it flexors of the elbow. They are three muscles: biceps brachii, brachialis, and brachioradialis. These three muscles share together in the formation of flexion of the elbow. Another example, extension of the elbow. The extensors group of the elbow are triceps brachii and anconeus on the posterior part of the upper limb. A muscle cannot reverse the movement it produces. This means that the biceps is flexors for the elbow. It cannot extend the elbow. The elbow should be extended by the triceps. The opposite muscle. Another muscle must undo the action. Muscle with opposite action lie on opposite side of the joint. Muscles with opposite action lie on opposite sides of the joint. These rules are clear for all of you. Then we will come to the third classification of the muscle. What we called it? Functional classification of the muscle. Very, very important for me to understand and memorize these definitions. Prime mover agonist has major responsibility for a certain movement. The prime mover, which we called it agonist, which has a major responsibility for a certain movement. Let us have an example. Flexion of the elbow. The prime mover for flexion of the elbow is the agonist. Antagonist opposes or reverses the movement. The antagonist for flexion of the elbow is the extensors. So the extensors oppose or reverse the movement. The triceps brachii is the antagonist for the biceps brachii. Synergists help the prime movement either by adding extra force and by reducing undesirable movement. Synergist means a helper factor. You remember in the chemistry, we add some materials to facilitate the reaction, to make the reaction easier. Here is synergistic muscle. I mentioned to you that the flexion of the elbow, three muscles are shared. Brachialis, we make it the prime mover, right? Synergists are the biceps and the brachioradialis. They help the action. Then fixator, this is a type of synergist that hold the bone firmly in place while a prime mover is contracted. Okay, you wanted to carry your bag and you wanted to keep your elbow flexed. We agreed that the prime mover is the brachialis, right? But while we are carrying our bag, we don't want our hand to extend all of a sudden. This means that we need a muscle which hold the elbow joint firmly in the flexion position. Huh? The fixators will be the brachioradialis and the biceps. Understand? يبقى third classification of the muscles is the functional classification. Prime mover means agonist as a major responsibility for the movement. Antagonist opposes the action. Synergist help and maintain the action. Fixator maintain the joint in position. Let us have another example over the lower limb. We agreed that the anterior compartment of the lower limb are extensors, while the posterior compartment are flexors. So the prime mover, we want to extend our knee. So the prime mover, the agonist, will be the quadriceps femoris. The antagonist, which opposes the action, will be the hamstring groove. The synergist in the prime mover, I mentioned it is quadriceps femoris, 4 muscles. Vastus lateralis, vastus medialis, vastus intermedius, and rectus femoris. They help and fixate the knee joint in the extension type. Antagonist oppose the action will be by the hamstring groove, which is the biceps femoris and semitendinosus and membranosus. I need you to understand very well the functional classification of the muscle. Prime mover, antagonist, synergist, and fixator. Clear? So we have 3 classification of the muscle according to the abundancy and the endurance and the maintenance of its work as myoglobin, the mitochondria, and the action of the muscle. Then second classification according to the shape of arrangement of the fascicles. Third arrangement according to the functional group of the muscle. Right? Then the rule of the action of the muscle, the 4 rules for the action of the muscle is very clear. Now we will come to a very important point, which naming of the skeletal muscle. We name the skeletal muscle according to the location, the shape, and the relative size. According to the location, indicate where the muscle is located. For example, the brachialis, located in the arm. Biceps femoris, located in the thigh. Right? Pectoralis, pectoralis major, located on the pectoral region. Shape, named for particular shape. Example, the deltoid is triangular in shape. According to the size, like pectoralis major, pectoralis minor, gluteus maximus, gluteus medius, and minimus. Okay, this is according to the size. We can name the muscle according to the direction of the fibers. As you will learn in the next lecture, rectus abdominis, transversus abdominis, external oblique, internal oblique. Okay, transversus abdominis, the fibers are arranged transversely and located in the abdominal region. Right? The external oblique, the fibers are located externally and downwards and medially. Internal oblique, it is located internally and the fibers are oblique in direction downward and lateral. According to attachment, brachioradialis means that these muscles start in the brachium and in the radius. Number of origin, biceps means the muscle of the two heads. Triceps means the muscle has three heads. Quadriceps, four heads, according to the action. Flexor, extensor, adductor, or abductor. Okay, the muscle can be named after so many points. Let us have examples over our body. For example, frontalis. The frontalis is named after its location, right? Orbicularis oculi. This muscle is named according to its shape, the circular muscle around the eye. Zygomaticus. We have zygomaticus major and zygomaticus minor. These zygomaticus muscle originate from the zygomatic arch and inserted in the angle of the mouth, right? We have zygomaticus major, named according to the location and the size, and zygomaticus minor, named after the location and size. Then we have what we call orbicularis oris. Orbicularis oris means the round muscle around the mouth. Orbicularis, as we agreed, circular. So it is the circular muscle around the mouth. Okay, then we have temporalis. This is the muscle which is located over the temporal bone, right? Platysma, from its shape. We will learn in next lecture that it resembles a curtain. Trapezius, it is named after its shape. Deltoid, again after its shape. Sternocleidomastoid. This muscle is named after its origin and insertion. It is originated from the sternum and the clavicle and inserted in the mastoid process. Pectoralis major and pectoralis minor. They are named after their location and their size. Serratus anterior. It is named after its shape. وبعدين intercostal muscle. It is that respiratory muscle which is located between the ribs. Then we have triceps brachial, means the muscle of the three heads, three origin. Biceps brachial, the muscle of the two heads. Brachialis means that this muscle origin and inserted in the brachium, in the arm, right? Pronator teres. This muscle is named after its action, pronation of the carpals. Brachioradialis, named after its location, starts in the lower part of the brachium and ends in the lower end of the radius. Flexor carpi radialis. This muscle is named after its action, flexion of the carpals. Radialis, it is located towards the radius. Then we'll come to the iliopsoas. Iliopsoas, one of the major muscles inside our body. It is located, the iliacus muscle located over the iliac fossa and psoas muscle on both sides of the vertebral column. Then rectus femoris. Femoris means this muscle on the anterior of the thigh. Vastus lateralis, over the lateral part of the thigh. Vastus medialis, over the medial part of the thigh. Then fibularis longus. It is named after its anatomical position and its length. Extensor digitorum longus means the muscle which extends the toes. Tibialis anterior means the muscle which is located over the anterior surface of the tibia, right? Adductor longus This muscle is named after its action and length. Gracilis, this muscle is named after its shape. زمان كانوا بيقولوا لنا طويلة ورشيقة. Gracilis, the first muscle in the adductor group. Right? You have to apply the same for all the superficial muscle of the body in the posterior view. يعني مثلا rhomboides major. This muscle is named after its shape and size. Infraspinatus, named after its location in the infraspinous fossa. Then adductor magnus, named after its action and size. The hamstring group, biceps femoris, the muscle of the two heads located in the thigh. Okay, مثلا we have flexor carpi ulnaris, named after its action and its anatomical position, flexor carpi ulnaris. Okay, so the muscle could be named after different items. Okay, could be after its location, its size, its action, its shape. The muscle can be named after 2 or 3 items. Again, I am repeating the 5 golden rules of the muscles that I mentioned before. With a few exceptions, all skeletal muscles cross at least one joint. Logic or not, يعني the muscle which will flex the elbow should cross the elbow, right? The muscle which will extend the knee should cross the knee. The muscle which flex the knee should cross the knee. What I mean by cross the knee should be inserted after the knee. The muscle which flex the carpals should be inserted after the carpals. Okay, so the muscle should cross at least one joint which will act on it. Flex, extend, abduct, whatever, but it should cross that joint. Typically, the bulk of skeletal muscle lies proximal to the joint it crossed. Yes, always the insertion of the muscle in the form of a tendon. Strong fibrous sheath connect the muscle to its insertion point. All skeletal muscles have at least two attachments: origin and insertion. Origin and insertion. That you can ask me, if a muscle, for example, like the biceps brachii, has two heads and single insertion. It has two heads, one originates above the shoulder joint and one below the shoulder joint, and single insertion in the radius. This muscle will act on the two joints? Yes. It will affect the shoulder joint, it will flex the shoulder joint and flex also the elbow joint. يبقى the muscle has one origin, one insertion. Okay, the origin of the muscle could be 2, 3 origins, like the triceps has 3 heads, right? But single insertion. Okay, like you can ask me, some muscles have double insertion? Yes, you can read it in the book, like the adductor magnus muscle. Skeletal muscle can only pull, they never push. During contraction, a skeletal muscle insertion moves towards the origin. Usually, the insertion comes closer to the origin. Plus, these are the 5 golden rules for the action of the muscle. So, muscle mass dorsal to limb bones are extensors. Muscle mass ventral to limb bones are flexors, except for the lower limb. The rule that I mentioned, and I am repeating and I repeat it. Anterior compartment of the upper limb are flexors. while the posterior compartment are extensor. Muscles that cross one or more joints act on those joints, as the biceps and the triceps. They cross the shoulder joint and the elbow joint, so they work on the shoulder joint and the elbow joint. Muscle that crosses a joint anteriorly or posteriorly or medially or laterally produced anteriorly will produce flexion, posteriorly produce extension, medially abduction, laterally abduction. Muscles that cross or act only on any joint, both muscles and the joints share the same nerve supply. Very important. The muscle which will flex the elbow will have the same nerve supply like this muscle. Muscles tend to be found located within a group of muscle compartment that share same action, innervation, and blood supply. That's why I'm always telling anterior compartment of the thigh, posterior compartment of the thigh, medial, lateral, because they will have the same action, same innervation, and the same blood supply. Okay, you have to apply these rules over each and every muscle in this slide. يعني here the muscles of the muscle that crosses on the anterior side of the joint to produce flexion. For example, the pectoralis major. A muscle that crosses on the posterior side of a joint to produce extension, like the latissimus dorsi, the swimmer muscle. A muscle that crosses on the lateral side of the joint to produce adduction. But actually the deltoid muscle has three groups of fiber: anterior, middle, and posterior fibers. Each group of fiber has its action. So the muscle that cross on the lateral side of the shoulder joint produce abduction. A muscle that cross on the medial side of the joint produce adduction. A muscle that crosses the anterior side of the joint to produce flexion, pectoralis major. Latissimus dorsi produce extension. Okay, the deltoid muscle, the middle fiber anterolateral view, a muscle that crosses on the lateral side of the joint to produce abduction. A muscle that crosses on the medial side of the joint like teres major produce adduction. Please open your book and try to apply these golden rules over all and every muscles inside our body. Okay, this is the first lecture of the muscle. I received several emails asking you to do these lectures. I did it for you. Hopefully you get the maximum benefit. I'm ready to answer any emails you send it to me. Okay, inshallah, hopefully we see each other together very soon, inshallah. Okay, thank you so much. Okay, I'm ready to reply to any emails. Thank you.